As a renowned physicist and presenter, Cox has often described the pursuit of scientific knowledge as a journey filled with wonder and astonishment. Recent advancements at CERN have again lived up to this philosophy, delivering findings that challenge long-held assumptions about the universe's fundamental structure. In this discussion, Cox elaborates on how these discoveries, although unanticipated, open new doors for understanding the cosmos, emphasizing the importance of remaining open-minded in the pursuit of scientific truth. CERN, which houses the LHC, has long been a hub for exploring the fundamental building blocks of the universe. The LHC is the most powerful particle accelerator ever constructed and has already contributed to major breakthroughs, such as the discovery of the Higgs boson in 2012. However, the facility is far from reaching the limits of what it can reveal. Recently, new experiments have produced data that physicists like Cox find perplexing. These anomalies suggest that there is much more to the universe than what current theories predict. They may even lead to a paradigm shift in how we understand particle physics. One of the primary goals at CERN is to explore and test the standard model of particle physics, which has served as a reliable framework for explaining how particles interact with one another. The standard model has accurately predicted many phenomena and provided a strong foundation for experimental physics. However, as Cox pointed out, some of the recent findings challenge key aspects of this model. For instance, certain results hint at the existence of particles or forces that do not fit neatly into the standard model's framework. These anomalies have stirred excitement within the scientific community because they could point to the existence of new physics, a term used to describe phenomena that extend beyond our current understanding. One of the areas where CERN's discoveries are most tantalizing is in the realm of dark matter. Dark matter, which makes up approximately 27% of the universe, has remained elusive, with scientists unable to directly detect it. The LHC, through its high-energy collisions, is providing clues that could finally unlock the secrets of this mysterious substance. Cox emphasized that these recent experiments have the potential to yield insights into dark matter and how it interacts with ordinary matter. Another area of interest that Cox discussed is the behavior of subatomic particles known as neutrinos. Neutrinos are incredibly difficult to detect because they interact very weakly with other particles. Despite this, they are one of the most abundant particles in the universe, and studying them could provide answers to some of the biggest questions in cosmology. Recent results from CERN have suggested that neutrinos might exhibit behaviors that were previously unexpected, potentially pointing to new physics. This is significant because neutrinos are thought to play a key role in the formation of the universe as we know it. One of the more unexpected findings at CERN involves the muon, a particle similar to the electron but significantly heavier. In experiments conducted at the LHC, scientists observed that muons were behaving in a way that defied predictions made by the standard model. This muon anomaly has sparked a wave of new research and discussions among physicists. Brian Cox noted that if this anomaly is confirmed, it could represent one of the most important breakthroughs in particle physics in recent years, potentially leading to a new understanding of the forces that govern the universe. Cox also touched on the implications of these discoveries for our broader understanding of the cosmos. One of the overarching themes of modern physics is the quest to unify the four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The standard model successfully unifies three of these forces but leaves out gravity. The hope is that these new discoveries at CERN could help bridge this gap. If physicists can identify a way to incorporate gravity into the standard model, it would represent a monumental leap forward in our understanding of the universe. In addition to the scientific implications, Cox discussed the broader impact of CERN's work on society. He emphasized that while the discoveries being made at the LHC might seem esoteric or distant from everyday life, they have the potential to lead to real-world applications. For example, advances in particle physics have historically led to technological innovations, including the development of the World Wide Web, which originated at CERN. Cox is optimistic that the work being done at the LHC could lead to new technologies that transform industries ranging from medicine to computing. Another topic Cox explored is the role that the James Webb Space Telescope, JWST, could play in complementing the discoveries made at CERN. The JWST, which was launched as the most powerful space telescope ever constructed, is designed to observe the universe in unprecedented detail. By gathering data on the formation of galaxies, stars, and planets, the JWST could help scientists interpret some of the findings made at CERN, especially those related to dark matter and the early universe. The JWST has already provided stunning images of distant galaxies and nebulae, revealing details that were previously hidden from view. Its ability to observe infrared light allows it to peer through cosmic dust and gas, offering new insights into the structure of the universe. By comparing data from CERN with observations from the JWST, scientists hope to develop a more comprehensive picture of how the universe operates at both the largest and smallest scales. Cox is particularly excited about how the combination of CERN's experiments and the JWST's observations could help resolve some of the mysteries surrounding the early universe. One of the big questions in cosmology is how the universe evolved from its initial state after the Big Bang to the complex structure we observe today. CERN's experiments provide insights into the fundamental forces and particles that shaped the early universe, while the JWST allows us to see the remnants of these processes in action billions of years later. As Cox explained, the intersection of particle physics and astrophysics is a rich area of research that holds the potential to answer some of the most profound questions in science. For example, understanding how galaxies formed and evolved could shed light on the role that dark matter played in their development. At the same time, learning more about the nature of dark matter through particle collisions at the LHC could help scientists interpret the data collected by the JWST. One of the other intriguing areas of research Cox discussed is the search for supersymmetry, a theoretical framework that extends the standard model by proposing that every particle has a corresponding superpartner. Supersymmetry has been one of the leading theories in particle physics for decades, but so far, there has been no direct evidence to confirm its existence. However, recent experiments at CERN have produced results that might hint at the existence of these superpartner particles. If confirmed, this would be a major breakthrough, potentially providing answers to long-standing questions about the nature of matter and energy. Cox acknowledged that the search for supersymmetry has been challenging, and there is still much work to be done before any definitive conclusions can be drawn. However, he remains optimistic that the LHC will continue to provide valuable data that could eventually lead to the discovery of supersymmetric particles. If supersymmetry is confirmed, it could revolutionize our understanding of the universe, providing a framework for unifying the forces of nature and explaining the existence of dark matter. Beyond the scientific discoveries themselves, Cox also emphasized the importance of international collaboration in making these breakthroughs possible. CERN is a global effort, with scientists from around the world working together to push the boundaries of knowledge. This spirit of cooperation is essential, as the challenges of understanding the universe are too great for any one country or institution to tackle alone. The success of the LHC and the ongoing discoveries it produces are a testament to what can be achieved when nations pool their resources and expertise. As the discussion came to a close, Cox reflected on the excitement and uncertainty that comes with exploring the unknown. He noted that while the discoveries being made at CERN often raise more questions than they answer, this is precisely what makes science so exciting. Each new discovery opens the door to further inquiry, pushing the limits of what we know and inspiring future generations of scientists to continue the quest for knowledge. In conclusion, Brian Cox's discussion on the latest discoveries from CERN underscores the profound impact that these findings could have on our understanding of the universe. From challenging the standard model to providing clues about dark matter and supersymmetry, the work being done at the LHC is at the forefront of scientific discovery. As these experiments continue to yield new data, they will undoubtedly lead to more breakthroughs, further expanding the frontiers of human knowledge.